The Wood Truss Council of America, in association with the Building Systems Council of the National Association of Home Builders, presents Framing the American Dream. This educational demonstration project took place at the 1996 Builder Show in Houston, Texas. Two identical houses were completely framed at the same time using different construction techniques. The purpose was to compare the costs and the efficiencies of component construction and stick framing. Final calculation showed that the component-framed house required 253 fewer man-hours and saved more than $3,300 compared to the stick-frame version. Here's how it happened. Computer-aided design and engineering assure accuracy and structural integrity in the manufacture of components. Factory production lines take advantage of automation and computer controls to produce components of the highest quality. Fast installation of floor, wall, and roof components shortens field construction time, allowing a building to be closed in quickly. That means less potential weather-related damage to building materials or delays that could increase interest charges on construction financing. Components take less skilled labor to install. With a good set of layout drawings, the building goes together almost as easy as connecting the dots. There's less job site theft, too. It's not easy to walk off with components for a home repair project. And with component construction, there's less waste produced at the job site. With conventional joist framing, each joist must be inspected and properly crowned, then typically spaced 16 inches on center. Trusses are supplied in long lengths and spaced 24 inches on center, speeding the setting process. Open web floor trusses allow easy access for ducts, pipes, and wires. This attic frame truss spans from wall to wall. There's no need for interior bearing walls below the truss. Clear spans provide great design flexibility in interior planning and partitioning. Any truss profile can be created. The only limit is one's imagination. Now let's get into the details of framing the American dream. Every project begins with a good set of plans. Good planning up front will minimize problems on the job site. For framing the American dream, good sets of plans were provided to both framing crews so they would know exactly how to put each structure together. Component shipments come with framing plans for fast, efficient installation of each component piece. It is very rare to find a perfect set of plans. That's why component manufacturers use computers and engineering to work out any problems before the components get to the job site. Computer-aided design assures that the structure will perform as expected. All loads are accounted for and get to the proper location on the foundation. The building can even be engineered to optimize lumber use, saving money, and a valuable resource. Buildings can be viewed in 3 dimensions to make sure the architectural features and layout make sense. 3D has even been used to help framers visualize the framing, an extremely valuable service. With stick framing, all the planning is done right on the job. This can lead to a framing process that does not always go as smoothly as expected. Headers may be installed upside down, and hangers may be forgotten. And the rafters spliced when not enough pieces are brought to the job site. These all happen to our stick frame house. This stick frame house was built to comply with the building code. Every connection detail was reviewed to make sure the engineering requirements were met. The code allowed connection loads of 198 pounds, while the engineered connection required 280 pounds. Every now and then, even the building code does not meet engineering requirements. Yet both structures pass the framing inspection. That's why you get superior craftsmanship through engineering and manufacturing. With engineering completed, the cutting list is downloaded to computer-controlled saws to accurately cut the component members. There is no guesswork involved at the saw, so thousands of truss members can be cut in one day. This leads to a precision fitting joint every time, assuring high-quality trusses. Watching the smooth and efficient truss assembly and manufacturing process, it's easy to see how an entire roof can be built very quickly in the factory. The same concepts also apply to the wall panel manufacturing process. Component parts are computer designed for each specific building. They're precision cut and fabricated to create a wall section that has the right number of connections in the proper locations. Again, it is craftsmanship through engineering and manufacturing. A quality house starts with a good foundation. The dimensions must be accurate and the walls plumb and square. If this isn't done well, structural and cosmetic problems may result. Now let's look at the floor framing process. In a stick-built floor joist system, the maximum length piece is about 16 feet. Each piece is inspected for the proper crown and set in the desired location. The joists are then set upright and toe-nailed to the foundation wall. Typically, joists are lapped in the center of the span and nailed. Solid blocking is inserted to add rigidity and stabilize the floor system. The final step is to lay down the flooring. Notice that the nailing surface is only 1.5 inches wide, so considerable care must be taken to be sure that all the nails hit the joists properly. Floor truss construction is different. Floor trusses are manufactured in long lengths, yet they're easy to carry and set. The spacing is typically 24 inches on center versus the traditional 16 inches for stick-built floors, so floor truss installation is much faster. Even blocking is easier to place and secure. The floor truss system is tied together using 2x4 band boards and inserting strong back bracing. Installing these properly enhances floor performance. The wide surface available for attaching the sheathing speeds gluing and helps assure accurate nailing. Construction of the component frame floor system required 26 fewer man-hours and used 1,100 board feet of lumber less than the stick frame floor. When installing HVAC plumbing and electrical systems with joists, holes must be cut and chase runs dropped for plumbing and HVAC ducts. But the open web design of floor trusses saves time and money by allowing easy access for all mechanical systems. Chase runs are conveniently built into each truss, and the use of flexible plumbing and ducting makes the job easy. Now let's look at the wall framing process. Framing the walls on the job site floor deck is much more time-consuming than doing the same work in the factory. Each stud must be carried to the proper place, located 16 inches on center and lined up between the top plates. Then the entire assembly is nailed together. Notice that all the work on the floor deck requires bending over to accomplish the task. First, window and door headers are cut and placed. Then the wall is lifted into place. Once in the proper position, the wall is attached to the floor deck and braced. The same routine is used for each wall. Every now and then, special cuts must be made to make the wall framing work out right. This one is probably not OSHA approved. In many areas of the country, sheathing is applied to walls while it is still laying on the deck. In Houston, the sheathing was applied after the wall was set. Foundation adjustments were made with the walls. Either way, sheathing walls on site is very time-consuming. Wall panels for the component house were stacked at the factory in a specific sequence to make the shipping and setting process go smoothly. The exterior walls came to the job site sheathed and square for ease of installation. Each panel was marked for a specific location, and all the pieces were precision designed to fit together. Factory design engineering of panels helped speed installation because the interior wall layout of the houses was fairly complex. Notice all the angles that were built into the interior wall system and how the pieces fit nicely together. Any blocking required had been factory installed. Compare this to the stick-built house shown at the top. The component wall system required 66 fewer man-hours to frame than the stick-built. Board footage was identical. Now let's look at the second floor framing process. As shown here, the stick framing was quite complex given the number of pieces that had to be nailed together to provide the desired architectural effect. All the walls shown are load-bearing and cannot be removed. The second floor of the stick house was designed with 2x12 dimension lumber joists spaced at 16 inches on center, but long-length I-joists were substituted, which made the floor framing much faster. Notice a bearing wall was required. Next, the deck was placed and the upstairs bearing walls were built and lifted. With the second floor bearing walls in place, the rafters began going up. The lead carpenter calculated and made all the rafter cuts for the roof. Each stick was handed up to the crew for proper placement and connection. Both job sites were in compliance with the OSHA fall protection regulations. Notice that attaching the rafters was not an easy task, even with the help of high scaffold platforms. Field connections like this are difficult to make. The hurry up and wait syndrome was quite noticeable on the stick frame job site. A good set of plans was critical in getting all the pieces in the proper place. With the stick frame structure, there were many pieces to attend to. As the camera moves through the framing, notice the connection details that had to be precisely made. Once completed, the structure was very attractive. The component house arrived at those same attractive features in a far different way. The second floor was framed, beginning with a field fabricated girder truss section. It lifted into place by a crane. Once the girder was in place, the attic frame trusses were craned up and set. See how the second floor outside walls are built right in, and the trusses span from outside wall to outside wall. This provides a future remodeler with great interior wall flexibility. Notice also how quickly attic frame trusses can be set and secured. The wall system and ceiling profile are built into the trusses. Again, note the ease of setting on the bearing walls. The verticals are the wall studs for the room, and the 2x10 bottom cords are the floor. True cross bracing is very important for stability. When all the trusses are set and braced, the gable end is hoisted into place. The sheathing is pre-applied. The second floor is finished off with floor sheathing and interior walls. Since the trusses are too large to transport in one piece, small piggyback trusses are attached to the top of the attic frame trusses. The piggybacks are then attached firmly to purlins to complete the roof system. The component frame second floor system needed 83 fewer man-hours and 2,300 board feet less of lumber compared to the stick frame version. Stick framing the roof over the great room was quite complex. The first end wall glulam was hoisted into place. Then short ceiling joists were placed over each of the porch areas. A short knee wall was built for these roof rafters to sit on. Then this header. And the main ridge beam were placed. As you can tell by their size, this beam and header system carried all the loads from each of the roof rafters. Here you can see the double rafter system with a ridge board above and beam directly below. And all the connections that had to be made to make the system work. Attaching collar ties finished off the ceiling profile. Gable end wall studs and short rafters were attached to complete the look. The gable end truss for the component house was pre-built. Sheathing and the short sloping roof were applied on the ground. Then the entire gable end was lifted and swung into place. Computer-aided design had assured that the gable girder truss would fit onto the wall system quickly and easily. From there, each of the dual sloping scissors trusses were hoisted and set over the great room. The component roof framing went very quickly. This view shows how the ceiling profile was built into the truss. Once again, there were dramatic savings due to the speed of the component construction. 68.5 fewer man-hours and 1,525 board feet less lumber. The final framing to be done were the valleys. On the stick house, valley rafters were attached to a valley board placed on the top of the main rafters. Each valley rafter was individually cut with a compound miter and attached to the ridge board above and valley board below. The last step was to attach a vertical stud that would transfer the load from the valley rafters down to the main rafters. The component house valley framing was pre-built using small monotrusses connected to the top of the attic frame trusses. All the load transfer and connections required for this framing method were designed in the factory to ensure performance in the field. The component-framed valley saved 5 man-hours and 330 board feet of lumber compared to the stick-frame valley. Scrap generated at any job site costs builders money. It takes time to pick up, and there are dumpster and landfill costs. The stick frame site generated large amounts of lumber and panel scrap pieces, while the component site generated panel and bracing lumber scrap only. Component building is more environmentally friendly. The component framed home saved 13 yards of scrap and had $325 less scrap charges compared to the stick frame version. Here's a time-lapse look at the entire project. Overall, the component framed house required 253 fewer man-hours for a savings of $4,560 in labor costs. However, the component house lumber package cost $1,529 more than the stick frame house because it included the component manufacturing costs. Final totals show a net savings of $3,356 by the component house. The educational demonstration houses were built on the parking lot in front of the Astro Arena at the 1996 Builder Show. More than 9,000 builders enjoyed guided tours through the houses. This is a rendering of the dream houses before they were completed. They were dismantled after the show and trucked to two large lots outside of Houston, where they were finished out and prepared for sale. Proceeds of the house sales went to the Children's Miracle Network and Herman Children's Hospital to assist with the cost of treatment for children being treated for rare and complex diseases. With our dreams complete, we thank all our project sponsors and the many individuals who work so hard to make framing the American dream a success.